This is Algebra 2 with Trig, Unit 6A and 6B review. This is particularly the calculator portion of the review. We're going to look at an equation that's y equals 11,000 times 1.069. What is the value of the car in 1984? Well, we used this formula since 1984. So in 1984, it would be the A value, and the A value is 11,000. The growth factor. The factor is your multiple. So your growth factor is 1.069. By what percentage does it grow by? That does not include the 1, so we move the decimal spot over 2 and we get 6.9%. Here we have a decay model because we're multiplying by less than 1. What does the 54? That's our initial amount. The equation models the membership in an after-school athletic club. So that would be the number of people, it sounds like, that are in the club. Number of members starting in the club. It's the initial amount that we start with. So that would be the 54. What is the decay factor? The factor is 0.97. At what rate is this decaying in? Well, how far is this away from being 100%? It's 0.03. Then you move the decimal spot over 2, so it's 3%. This is 97%, so you're 3% away from 100%. We're going to deposit $250 into an account for a senior trip. The account pays 2.92% interest. We're going to compound this semi-annually, so that means twice a year. So our R value is going to be 0.0292, and our N value in this case is going to be 2. So A equals P 1 plus R over N to the NT power. So we're starting with $250, 1 plus 0.0292 divided by 2 to the 2 times 2, because we're doing this for 2 years. So T is also 2. So we're going to take our calculator and we'll do 250 to the 1 plus 0.0292 divided by 2. Order of operations is going to divide that first before it adds, so no problem. Raised to the power of 2 times 2. And that comes out to $264.92. Now, if we compound it monthly, we're still going to have 2 years. We're still going to have the same interest rate, but the N value is going to be 12, because that's the number of compounds per year when you do it by 12, when you do it by monthly. So A equals 250, 1 plus 0.0292 over 12, and this would be 12 times 2. $250, 1 plus 0.0292 divided by 12 raised to the power of 12 times 2, 24. And that's going to make a little bit extra, 265.02. because we're compounding it every month, we get a little bit of money each month. So by the second month, we have more than $250 in our account. And when we're doing the partial interest rate every month, it's on a larger and a larger amount each time. So that's why it actually is more beneficial to compound your interest than just to get your interest all at one time. Here in 1990, the population of Canton was 264,200. During the next 10 years, the population increased by 3.2%. Write a model giving the population after 1990. So we would say that the amount that we have, P, 1 plus R to the T. That's the formula we'd be using. It's not a compound interest. It's not divided by N. It's just our interest rate, and we do that calculation once a year. So we're starting out with 264,200 people at 1 plus 0.032 to the T power. So if you combine that all together now, we would have 264,200, 1.032 T. What was the population in 2008? Now, I feel this could be a little bit of a mistake because they say that this works for 10 years. This is over the 10-year marker. This is 18 years since 1990. But we don't have any other data, so we have to be using the same formula. So if you want to consider this 20 years, it follows this pattern for 20 years, that would be even better. So we're going to take our 264,200 to the 1.032 for 18 years, because 2008 minus 1990 should be 18. 2008 minus 1990 should be 18. That's where we get that from. Now we say 264,200 to the 1.02 or 1.032 to the 18th, because we're going to do this for 18 years. So 18 years later, this has grown to 465,765 and some partial people. Graph the model on our calculator. Estimate the year when the population was 340,000. So 340,000. When we put it into our calculator, we're putting the 264,200 to the 1.032 raised to our x. And we want to know, when is this going to cross 3,0,0,0? So we can look at our table, and we can see that we're going to be closest right around here, 8, very close to 8. So we're going to be up near our 340,000 after 8 years. So we're going to go to Windows, and we're going to push this guy up over our 340,000. So I took it up to 500,000. So slowly but surely it's growing. And then this should be our 340,000. We want to know where they cross at. So second trace takes us to intersect. And it asked us a few questions. This is your first equation. We hit enter. Is this our second equation? We hit enter. And then it says guess, which means get your cursor closer to it if necessary. But because this is exponential, it doesn't curve back up. It's not a parabola. So you can hit your enter key at any point, and you're going to get 8.0079. So in our sketch, we see that we are slowly growing up with a horizontal line, and this spot here would be x equals 8.0. And if we want to get technical, we can just share that it is 8.0079. That would round to be 0.8008, just to show that it's not exactly on a number. It's a little bit after 8 years. Okay, why do you think anyone would move to Ohio? I don't think that's a real question. All right, Canton, Ohio. That would be, I didn't even realize it was Ohio. That's a Hall of Fame for football. Okay, a new Dell computer costs $2,600. The value of the computer decreases. When you buy it, it's not worth as much after time. Write a model giving the cost of C of the computer. So C equals the amount that we're starting with, 1 plus 15% is 0.15, and actually this is a decrease, isn't it? It's a decrease, so it's going to be a minus to the t power. We're using the pattern formula because it's a decrease rate question. So 2,600, 0.85 to the t power. How much will it be worth after 2 years? You want to sell your computer. 1 minus is going to be 0.85 for 2 years. And we get $1,878. And 50 cents. After how many years will it be worth $600? So we have a couple different ways we could do this. If we can use our calculator, we don't have to solve for the exponent, but we have the skills to actually solve for the exponent. If we wanted this to be 600, and we're starting out with 2,600, we could divide by 2,600. And that gives us 0.2307 equals 0.5 or 85t. And if we were to write this as a logarithm, we would have log 0.85 0.2307 equals t, and we would need to calculate what that would be. Now we're really close to being able to answer that, but we don't have our calculation for that. There's actually a method to do that. Alright, the answer that I came up with was 9.02. Now let's see if we can do that with our graphing. If we were to graph this out, we'd type in our equation, and our equation be right here. 2,600 to the 0.85 raised to the power, and we want to know when is this going to cross 600. Look at table. I'm expecting this to be really close to 9. Okay, so there's 9. So in my window, I can have this, doesn't have to be nearly as high. So if we graph it out, we get our exponential. Barely crossing over here, because you're right, it's going to be out here near 9. Well, we can go to second trace, down to intersect, first curve, second curve, and guess. Move over here to get to it, and hit enter, and we get 9.02. 9.02. Priceless. So those would be two different ways. We just got to learn how to type this into our calculator. And he wants to buy a new couch in 3 years. The couch costs $1,500. How much should she deposit now? And a 6% compounded quarterly. 1 plus R over N T. There's our quarterly, or our compound interest formula. If we're going to do quarterly, we know that the N's going to be 12. We know we're doing 6%, so that's 0.06. And T is going to be in 3 years. The P value, the initial starting value, is 1,500. So 1,500, 1 plus 0.06 over 12, and it's 12 times 3 years. So we've got 1,500, 1 plus 0.06 divided by 12 raised to the 12 times 3, which is 36. And we're getting approximately 1795.02. Evaluate using a calculator. So we know how to hit the log button. So this is asking 10 to what power is 7, so that's less than 1. And it's asking us to round to the nearest thousand, so tenths, hundredths, thousandths. So that's approximately that value. So this is e to what power equals 6. Approximately 1.792 because we would round up. And this is 0.4 e to the 4.1. The E button is here above the LN. So you got to hit the second LN button for you to get the E to come up, and you want it to the 4.1 power, and that gives us 24,136. Here we're going to do a graph. We know because it's E, it would be exponential growth, but because the R value is negative, we know that it's going to fall down. It's going to decrease, exponential decay. That's going to be translated 2 units to the right and 1 unit up. So we have an asymptote here where y equals 1. This would be exponential decay because the r value is less than 0. The asymptote is y equals 1. The domain's all real numbers. You can plug in any number in here for x. The range is any value greater than 1. And our end behavior, as x approaches negative infinity, the y value is increasing. It's going upwards. As x approaches positive infinity, the y value, farther to the right you go, the more it approaches the asymptote. We're investing $5,000 to start college. We have a rate of 2.35. How much would we need after 4 years if we have compound interest monthly? So compound interest, remember, is 1 plus r over n, nt. So we're starting with 5,000. 1 plus 0.0235. Monthly would be 12. So this is 12 times 5. 5,000. 1 plus 0.0235 divided by 12. Raised to the 12 times 5, which is 60. And if we compounded it continuously, continuously is the Pert formula. So we're still starting with $5,000. E to our decimal of our interest rate times the number of years oh, it was 4 years, not 5 years. We got to go back and change that, huh? So 4 years. So we're 5 e to the 0.0235 times 4. So that's approximately, I have 5, not 5,000. So the decimal spot's just going to slide over. Watch this. So 0.0235 times 4. We get our same numbers, but the decimal spot slides over. 5492.80. And over here, we actually need to redo that one. And we need to tell it that we're going to compound it for 4 years. So that changes the result a little bit. 492.29. Okay, in 2 years you want to have $5,000 in your account. Find the amount you should deposit if you get 3% compounded continuously. So you want $5,000 in your account. How much? That's P, E, R, T, 2 years. Concentrate on that one. So we want to get the P all by itself. So let's figure out what E to this power equals. So E to the 0.03 times 2. So we're going to take 5,000 and we're going to divide by the real answer. So I'm going to say answer, and that can be found under your negative button. And that gives us $4,708. Then on the flip side, we got a couple of factoring questions. Notice this has 4 parts to it. So I would expect that we would do factor by grouping. We can factor out a 25. That would be 7x minus a negative, and a negative makes a positive. So we get x squared minus 25 times 7x minus 2. This is still the difference of 2 squares. And we factored it. Factor our next one. I don't see a GCF, so we could multiply, but that would just be ginormous. I'm going to use a guess and check. Let's see if we can come up with this. I'm betting 5 and 3. Now I got to come up with something that multiplies to be 2. So 6 and 4, that would be 30, and 4 would be 6 and 4, that would be 30 and 12, that doesn't get to 2. 20 and 8, oh, 20 and 18, just did it. 5x times 3x. If this was the 4, so that would give us 20. And if this was a 6, this would give us 18. So actually this has got to be a negative 20 and a positive 16. 18. So I first guessed at it, and then I checked it. So 5 times 3 is 15. 20, negative 20 plus 18 gives us negative 2, and it multiplies together to be negative 24. That's one way to do it. Another way would have been to say 24 times 15, and we would have gotten negative 360. That adds to be negative 2. Then you would want to come up with 2 factors that were just 2 apart from each other. Okay, so you want 2 factors, 2 apart. 360 is such a huge one. We've got 10 times 36. The larger number has to be negative. We've got 20 times 18. Ooh, 20 times 18. That's 2 apart. Negative 2. So what we would do would be 15x squared minus 20x plus 18x minus 24. And we could use factor by grouping if we wanted to. So you can factor out a 5x. That leaves us 3x minus 4. Bring down your sign. Factor out a 6. That leaves us 3x minus 4. And we finish this off with 5x plus 6 and 3x minus 4, which is the same thing we got with guess and check. So if guess and check works for you, dynamite. If not, you need to use factor by grouping. We move over here. It looks like we have a GCF we can pull out. So 2x leaves us with 20x squared plus 7x minus 3. Again, not a super easy one to factor. We could use factor by grouping, which was looking for negative 60. That adds to be 7. So if you know that number off the top of your head, or you just run through your factors. Don't bounce around too much. We bounced a little bit over here because it was so many. Trying to save a little bit of time. But we know that the larger number has to be positive, so negative 1 and 60, negative 2 and 30, negative 3 and 20, negative 4 and 15, negative 5 and 12. There's your 7. So we would say 20x squared minus 5x plus 12x minus 3, and we can just use factor by grouping method to factor this apart. Pull out our 3, which would be 3 times 4 to give us 12, and 3 times 1 to give us 3. And as long as these match, which is required, you get 5x plus 3 and 4x minus 1. Don't forget your original GCF. Otherwise, you would use guess and check, which could have been 10 and 2, which could have been 5 and 4. Anyway, that's factoring. Now, this one is x to the 4th, but because this is 4 and this is half of that amount, like 6 and 3 or 10 and 5, this is 4 and 2, we can treat it just like any quadratic. So x squared times x squared, they multiply together to give us x to the 4th. 6 and 5 are 1 apart from each other, so negative 6 and a positive 1 would give us negative 1 when added and negative 30 when multiplied. Neither of those are difference of two squares, so we factored it. Good luck.